we'll discuss about first the atomic number and mass number. The presence of the positive charge in the nucleus. We know that there is a positive charge in the nucleus. We understood this from the Rutherford's atomic model, which one I described in the class number 013. And this positive charge is due to the protons in the nucleus. We know that the charge of the proton is equal but opposite to the charge of the electron. The number of protons present in the nucleus is equal to the atomic number Z, capital Z. For example, the number of proton in the hydrogen nucleus is 1 and in sodium ion it is the 11. So the atomic number for the hydrogen will be 1 and for the sodium it will be the 11 atomic number. In order to keep the electrical neutrality, that means number of protons should be the same, the number of the electrons, and its atomic number is Z. Now, example, the number of electrons in the hydrogen is the 1 and for sodium it is the 11. So the atomic number Z, it is also equal to the number of the proton in the nucleus of the atom and the number of the electrons in a neutral atom. We have to mention here neutral, because if some ion is there, then it will be the short or more than electrons than protons. So always you have to mention the for the neutral atoms electrons number, it is equal to the number of protons in the nucleus of that particular atom. While the positive charge of the nucleus is due to the proton, the mass of the nucleus is due to the both protons and neutrons. So the protons and neutrons present in a nucleus, we know that in nucleus, except hydrogen, hydrogen has only proton, but for other elements, atoms, the nucleus consists of the both protons and neutrons, and it collectively called as the nucleons. So the total number of nucleons, what it is called the mass number. So the mass number, which is denoted by the capital A, it is the sum of the number of proton denoted by the capital Z and the number of the neutrons denoted by the small n. Now we will discuss about what is the isobars and what is the isotopes. The composition of any atom can be represented by using the normal element symbol capital X with superscript is the mass number denoted by the capital A and subscript the atomic number denoted by the capital Z. So then the symbol will be with mass number and atomic number, it will be like that. Capital A superscript capital Z, capital Z subscript, and the element symbol is X. In this way, we can represent it. And when it is the isobar, then example, you see 14C6 and 14N7. So in this case, you see the mass number for the both atoms is the same, but for the atomic number for the both atoms or both elements, it is the difference. In the first case, for the carbon, atomic number is 6, and for nitrogen, the atomic number is the 7. But due to the adjustment with the neutrons, both mass number for both cases it is the same. That means for the 14,6C, in this case, the neutron will be 14 minus 6 is equal to 8. But for the 14N7, in this case, neutron is the 14 minus 7 is equal to 7. So then these two atoms are called isobars. Now, atoms with identical atomic number but different in mass number is known as the isotopes. You have to remember, in first case is the atomic number and second case the atomic mass. You have to include the mass number. And atoms with the same atomic numbers but different in the mass number, it is called then the isotopes. And it is evident that the difference between the isotopes is due to the presence of different number of neutrons present in the nucleus. So considering, we'll take one example for the hydrogen. Hydrogen consists of the protium, which is denoted by 1H1. It is the percentage 99.985%. Rest of the percent of the hydrogen atoms is contain the two other isotopes. It is deuterium denoted by the 2D1, which has the 0.015%, and the another isotope is the tritium denoted by the 3T1, and it contains the 1 proton and 2 neutrons. And the isotopes found in trace amounts. Other examples of the commonly occurring isotopes are for the carbon atom, you'll get the 3 isotopes, 12C6, 13C6 and 14C6. And for the chlorine atom, you'll find the two different isotopes, 35Cl17 and 37Cl17. So now we understood that what is the isobars and what is the isotopes, what is the difference between them. Another important point we have to remember that for the isotope, we know that atomic number is same for both isotopic atoms. So atomic numbers denotes the properties of that atom. Atomic number defines the chemical properties of that particular atoms, because these atomic numbers is again equal to the number of the electrons in neutral atoms. So another way you can tell that number of neutrons in the nucleus has very little effect on the chemical properties of an element. Chemical properties of element only determined by the number of electrons, which again is equal to the atomic number, that means the proton of the atoms of that particular element. So we can conclude that all the isotopes of a given element show the same chemical behavior. So now we see that small problem number 1, that one calculate the number of protons and neutrons and electrons for the 80 Br35. So you understood that this is the atomic number. So which one will be the equal to the electron number, and neutron number is equal to this one 80 minus down one 35. So in this case it is the 45. So it is written there. So in this way we can solve the problem. You will be given with one symbol, and out of this you have to calculate the proton, neutron and electrons. Another problem is that the number of electrons, protons and neutrons is given just opposite. So assign the proper symbol of the species. So you see that electron and proton, electron, proton and neutron. So in this case, the neutron and proton, how much? 16 plus 16. So 16 plus 16, they'll do 32. So in the symbol superscript left side will be the 32. Then symbol will be the X. Now down, what I have to do? And down, if you see, the symbol will be it is not the neutral atom, because the thing is that you see that there is the difference between the electrons and protons, and that is the 2. That means 2 electron is extra. So in this case 2 electron is extra means its charge will be the 2 minus, and down only the atomic number. What is the atomic number? Atomic number is the 16. Okay. So in this way we can write the proper symbol of the particular species. I think you understood clearly. Isotope, bars, atomic numbers, mass numbers, electron numbers, etc.